The new Hunter FS3000 and FS1000 field servers make it easy to communicate directly with Hunter ACC2 and ICC2 controllers from centralized command centers. Hunter's high-performance field servers connect the irrigation system to a configurable building and industrial automation gateway. Integrators can easily interface irrigation control from Hunter ACC2 and ICC2 controllers to networks in commercial buildings, industrial plants, and smart cities. So, to tell you more about this exciting new product, we have Dave Schaub, Category Manager for Central Control. Dave, you have the floor.
Thank you, Greg. Yeah, my little catchphrase is don't stress, the answer is yes. So this has always been a little bit of a mysterious interface for people, and it comes up pretty frequently in the irrigation world where existing SCADA type systems or building management systems want to incorporate irrigation control. So a few years ago, we just started playing with that. And we got places, and then we started doing some really serious projects, and it became important enough to put directly in the product line. We have developed considerable expertise in this now, and that's why I say don't stress. The answer is yes. You don't have to be an expert on these kinds of systems. You just have to know that they're possible. And we achieve this through this specialized hardware, the FS1000 and FS3000. We call these field servers. They're often commonly known as gateways, interchangeable terms. And the little boxes serve as a translator between the network protocol and the proprietary Hunter controller protocols, which are very well established and very well documented. And these kinds of systems actually allow developers to discover the controller objects to add to their control screens, and we can see one in the picture there, and includes all the documentation they would require. It essentially allows them direct access to every single command and report in our controllers. The box is fortunately not actual size, it's just there to show it, and it is only 4 inches tall, and we'll take a look, but they work with either ICC2 or ACC2. And the numbers refer to the number of data points, and the 1,000 data points or 3,000 data points is determined by how many controller features they plan to implement. You can actually operate more than one controller with a single gateway or field server, depending on the degree to which they're going to integrate it. For example, an FS3000 could probably operate 2 to 4 ACC2 controllers because most users don't actually implement every single feature of that controller. They could, but it's unlikely. Whereas ICC2 controllers might lend themselves to the FS1000, which is a little more economical and could handle multiple controllers. It is a big opportunity. So what's sort of generically referred to as automation systems are custom software platforms that manage all the utilities within a given facility or city. And these types of secure systems typically cannot use the internet. They don't want to hear about Hydrowise or Centralis or any other web-based control because it's a significant security liability or vulnerability for these enclosed systems. So the users and or their system integrators, the people that make these lovely screens, actually create their own software controls and can then integrate the irrigation with other systems within the network. We've been doing this now for several years with great success, and that's a beautiful screen there and a good example of what can be done. Some of the keywords we're going to find are BMS, Building Management Systems. The opportunity has gotten bigger than just buildings, but that's how we hear it referred to in the US quite a bit. Another term is BAS, Building Automation Systems. I think maybe a better general technical acronym is SCADA, which stands for Supervisory Control and Data Acquisition, but the term SCADA has been around a long time for these types of interactive networks. And lately, what we hear more is smart city for citywide automation control. They're kind of all derivations of the same idea, which is rooted in the air conditioning industry. And then once they had these networks that could talk to so many devices, the role began to expand. And now here we are today. A couple of network terms that we'll hear a lot, and sometimes this is how our initial question is phrased to us, is BACnet. Can you interface with a BACnet system? Modbus. Modbus has been around longer than BACnet. BACnet is kind of a refinement thereof, and both of those are very common in domestic and international. And the answer is yes. Another one that a lot of developers like is interfacing via RESTful API. And without getting into a lot of technical detail, yes, we do that. In fact, we have over 120 industrial protocols at our fingertips, and we've interfaced with some outside the norm. One that jumps out is DMP3, which was a network for kind of the energy industry for utilities. And yeah, we have done that and very successfully. This is not our typical sprinkler customer. The user probably is, but now we're going to deal with network engineers who have security and protocol concerns, and they're the ones who operate these systems within a firewall. Then we deal with system integrators, and these may work for the user, or they may be on a contract basis for the user. They're the ones that actually turn the commands into screens and draw buttons and forms around the commands that allows it to interact with irrigation. Irrigation designers also, while they're often not network experts, they don't really need to be, but they're a pretty vital link that know how irrigation work and kind of understand what users need to do and perhaps how we could interact with other things. So they can be as involved in the process as they wish, or they can just spec it and others will work that out. And finally, there's the poor user, the irrigation control manager. They need a system they can actually use that can get reports and alarms and program controllers and schedule irrigation. So at some point, we try to get all those people in the same room or the same call and kind of hash out what it is what is our dream? What do we want this to look like when it's done? And it really truly is about sustainability on the grand scale. It is wide area management of anything that consumes resources within a given facility or city. It can provide automated adjustment, detailed reporting, and interactions with other devices. And the scope of some of these systems is quite breathtaking. Our field server devices can be located anywhere in the network. Generally, we will connect our controller to the network with a LAN or Ethernet module. And we have one for ACC2, one for ICC2. The field servers can be installed right in the controller or co-located with the controller, but they don't have to be. They could be in a nearby building that has a connection to the network. And as we see on the right there, they can be in a server rack mount. They can be anywhere in the network, and the servers and the controllers will find each other as if by magic. It is technically possible to connect via cell and or Wi-Fi, but these are not preferred connections. Again, the security issue is paramount for these customers. So generally, it'll be a hardwired Ethernet connection. And otherwise, other than knowing what module we need to connect, it's not real important to the design process. They use a lot of terminology, and a couple of things that come up are irrigation controllers are referred to by network people as devices. They're kind of peers of an air conditioning motor. The features of the controller are considered objects, and different objects have different sizes, and that's where the data points come in. Some very simple objects may only have 1 or 2 data points. Some may have quite a few more, and they're just the properties of the feature. So the feature requirements, what they actually want to do in terms of scheduling, defines the size and capacity of the field servers. When we get those folks together in a call, we'll get a pretty good picture of the expectation And then we can determine the most economical way to reach the controllers with either the 1,000 or 3,000 data point servers. And as I mentioned, a single 3,000 point field server could accommodate 2 to 4 ACC2 controllers, depending. And there's a photo of a development station where a system integrator is actually experimenting with the commands and building an entire interface. The field server also comes packaged with what I'll call demo or starter software. So the software screen designs will resemble our Centralis central control software, but they have nothing to do with that. It's an onboard direct access piece of software that runs in a browser and can be used to talk to a controller. Many customers really won't want that. They're going to want to blend our controls into their bigger picture. But they can also use this as kind of a tutorial to see how we connect a controller to the BACnet or the Modbus or whatever, and also just to see how irrigation is organized. That they don't necessarily have tribal knowledge of the irrigation business, so you can't just turn all the stations on at once. You've got to organize it into schedules with station data and so forth. So this is a very helpful piece that's just built in there, whether they choose to use it or not. And it can be used virtually immediately. If you choose to use it just like this, you can start talking to ACC2 controllers and making them dance instantly. This is the high-level checklist I sort of use to identify projects, or a shortened version of it. Identify the key stakeholders. We want to know who's in charge of the network for our purposes and security questions. We want to know who the system integrator is and who the irrigation managers are. It is helpful, actually necessary, to know the network protocol, but we can always ask the integrators or the network guys directly. We'd like to know the software user interface of the development platform. Wonderware is one example of popular software that is configurable to operate these systems. There are many others. And then the final thing for extra credit is define interactions between the irrigation system and other devices within the automation ecosystem, because these can also be talking to pump stations, tank level monitors, flow sensors that are located elsewhere and not connected to controllers, weather stations. All these devices, if they're in the network, can be made to or allowed to interact with the irrigation controls. This is an example of a form we use for a use case, and this is one that comes up a lot: reacting with fire alarms. So the fire alarm system is already present in the SCADA system, and that's very common. Well, when the fire alarm goes active and there is a fire, we want to immediately terminate all irrigation, and this can be automated. And that allows all the pressure and flow to be available to the firefighters. So this is a pretty common example of a relatively simple interface. The fire alarm is the trigger, and this is just a use case document. Describes how the SCADA is going to monitor the fire alarm, then reacts with a shutdown command to all the irrigation controllers. And if there are, well, this goes into some detail. If there's other water sources that aren't affected by the alarm, we could isolate those and just shut down the ones that would impact the water availability. Other examples of things that can be integrated. All we have to do is define what we want them to do. A weather station that's present in the SCADA, a rain sensor that's located elsewhere, flow sensors. There are flow sensors that can work with Modbus, TCP, or other protocols and report their flow data directly to the network. And then that information can be used to adjust, cancel, or increase irrigation. Tank level sensing, that comes up a lot in the larger municipal systems. This tank is getting low. I want to switch the water source to a different tank. Detailed flow consumption. Manual operation violations, that's a big water waster because in manual irrigation, it's pretty possible to get distracted, turn on a hose or a quick coupler, and then walk away and forget. And the thing is running all night. This system and that feature there can detect that flow is occurring when nothing should be running automatically. And if a master valve is present, execute an automatic shutdown. Real-time electrical power monitoring, low pressure responses, all kinds of pump station interactions. All of these devices are available with Modbus or BACnet interfaces in some form or another, and we can make them interact with irrigation control. And we have had a lot of success with this. We now have hundreds of these field servers in systems by Schneider Electric, Johnson Control, Honeywell, Siemens, the list goes on. These are the really big names and the really big providers of these SCADA type systems. And I have to say that in many cases, they don't even know our little irrigation industry exists. But it doesn't matter because we know we can work in their protocols. And then the system integrator pretty much takes it from there. The field server is American made. Programming and support is all from Canada and is compatible with ICC2 and ACC2 so far. We have done a lot of mega projects, and probably Abu Dhabi is where we started, the Abu Dhabi municipality, which was a DMP3 system. And now that's moved up the coast a little bit to Dubai municipality. One of the really pretty ones that was in some of the screens I showed is Madinti or Madinati in Egypt. The new capital of Cairo, which is built outside of the Cairo we tend to think of. And then a separate project within that is the Presidential Palace, which is a huge system. Both of those are automated in this manner. King Abdullah International Gardens in Kingdom of Saudi Arabia, another example. There are many more, but I'll just move along. And at that point, that's the overview of what we're launching. And now I'd look for any questions.
All right, Dave, we'll stay here for just a moment while we wait for any questions that come in. We have not gotten any questions along the way, so we will just stay tuned for those. We'll give it about 3 or 4 minutes. If we don't see any questions coming through, we'll finish up the presentation. But great job. Well done. I learned a lot from that presentation, so thank you.
I guess I should add that our global application engineer, Adil Ahmed in Cairo, is probably the foremost expert in the irrigation industry on integrating with SCADA type systems. And he is at all of our beck and call to work on the details and work with the developers, and has learned a great deal. And my knowledge would pale compared to his. Tremendous resource.
Do you have any recommendations for websites that people could learn more about this technology, through Hunter Industries, or just more about the central kind of control network that you were discussing?
If you search on BACnet, there's BACnet.org, who is it's kind of an open source approach to developing the automation software, and it is a wealth of knowledge. And that's probably where I started. BACnet.org.
Fantastic.
And you branch out from that, they have a lot of links.
BACnet.org. Just put that in the chat. So if you are interested in following along with that, it's right there for you. Do you know of any site studies that?
Working on those right now, Greg. One thing I should mention, these sites are custom and they are kind of private property, I'd say. And there are some security concerns. So you can't just walk around and snap photos and start writing everything up. But I'm pretty careful about getting permissions to do that. And I want to go into detail on what we've done at several of these showcase sites. And that's all on the work.
Fantastic.
I would point out we also, in conjunction with this launch, created a Smart Cities brochure, which is available from our digital assets library and through any Hunter salesperson. And that at a high level kind of goes through a print version of what I just described.
All righty. Well, I did not see any other questions coming in to the chat or the Q&A. So I believe that's it. Thank you very much, Dave. Anything else before we sign off here?
Negative. Thanks to all for attending.